It seems quite quiet. Is that?
Okay, so I can see video.
Can we test audio? We might get some feedback. Yep.
How about the slides? So the slides are not being shared.
Yes, we need to share the slides. So, sorry. Share. I think it's best just to do it as a screen share like that, right?
Yeah, of course. So that screen's being shared. This screen has notes. Is that right?
That's right.
Super. Well, this looks like it's working. Okay, great. Yeah, we're set. Just to wait for people to turn up now, I suppose. About 15 minutes.
Okay.
I can go and get you a cup of coffee if you like, or a tea, or a water.
Oh yeah, the tea.
Tea?
Yeah, fine. Yeah.
What kind of tea we have?
Just a normal English tea
English
with
tea.
milk, no sugar.
Milk, no sugar. Okay.
Yeah,
I'll
thank
sort
you.
that out for you, no problem. Is that you or anything on there?
I'm okay, thanks.
I see how the video the video to be played. I see.
Okay, that's a good thing to check.
This mouse system is a no.
It's got so above and below. There is a scroll, but it's like a button rather than a wheel.
Okay. So there's one video here.
Okay.
And okay, just the how do you
It's kind of right. So we're still on the first slide on the screen.
all right.
Sorry, I'll just check with. Yeah, be on my screen. Hello. Let's check there.
Yeah. Okay. Right. I just needed to press this button, right?
Yeah. So it'll be on this screen.
How I play it if I wanted to. It seems I cannot see my cursor.
Yeah.
So I needed to.
Let's see if there's a better way to do a slideshow than this. Sorry.
Just the 2 videos, so not many.
Oh, that's great. You don't have to let anyone in yet. Please present some views, that's it. That's better. Okay. So this will look like this now. Is that better? So
Okay. All right.
And then you have your notes there.
All right. Could make this a bit slightly bigger. And how to move that?
So if you minimize the teams, then yeah, you can press the minimize and that'll be fine.
Okay. Okay.
Okay.
Right.
And is that okay with the next slide being that big? Or you can make that smaller if you're just wanting it to say.
How do you want to make it?
That's better.
Okay. Right.
Right.
Then just press this. Okay.
Yeah, I'll just share screen again so that we're. Perfect. Okay, Wait until Mark's back, and then we'll start letting people in so that you can introduce you. And Ricardo's quite keen. He's already waiting in the lobby 10 minutes early.
Is that you introduce me how I introduce myself?
Mark will introduce you.
Okay.
And then hand you over to your presentation.
All right. Yeah. Okay.
And then afterwards, we normally have question and answers, if that's okay.
Okay. All right.
Okay. Looks like Mark's doing this side of the tech. Yeah. Oh, that went a lot more smoothly than it normally does.
Really? Yeah, for this IT stuff, there always something.
Even just
instance,
the room booking. So last week we showed up to the room and there was someone teaching a lesson. And so we had to take everyone from that room back to here and find a room that was free. And then the camera didn't work and then the microphone stopped working. Just played it really cool. Yeah, well prepared today. This is good. You say it and then it's gonna go wrong.
So the video, I just click on the video, or is it actually play?
You can click or it should come up.
Let's see.
Yeah.
There.
I think if you click there.
Okay, all right.
And
right.
then it'll show up on that screen, and then it'll get shared onto that screen.
Okay.
Yeah, that's working fine.
Then this have another video.
Are there any sounds on the video? Is it just animations?
The sound, just the music. Is okay without sound.
Okay, we can get the music if you want.
No, it's not really great need for sound. It's okay. I think I probably want to explain that one.
Okay,
How many students your institute, Acoustic Institute, have?
In acoustics,
yeah.
I'm not sure exactly, but I think it's about 30 per year.
All right.
So maybe...
And the Salford probably is the largest, Salford and Southampton.
That's right.
Yeah. Have the largest group of acoustic.
Yeah. So I did my undergrad in Southampton.
Oh.
Here's a cup of tea, and we have our first attendee.
Like the first attendee.
We have got someone waiting online.
Okay.
We're going to sit in the back room, it'd be cool. Yeah. So I'm meeting one. Hi.
So that's a lunchtime seminar.
We'll start waiting. I'll come back at 12 when it's actually inside.
They're all coming, they're downstairs.
Right. This is the thing. Do we have a seminars It looks like I'm doing every presentation.
Yes.
I'm sure you made a meeting.
It's my meeting.
Yeah, since I've done the text.
But since you've done the tech, it's coming up as.
But
But
I can rename it.
doesn't matter very much.
It doesn't matter. It doesn't exist. Any questions? Yeah. And you'll have to do the instructions.
Yes, the construction. Essentially, I'd like to see some of the facilities
Oh, great. Yeah.
after the talk, so I could do my own that because I still
Yeah.
don't know how the stuff is. So.
Absolutely. I think the final year undergrads are also doing their poster presentations, so
Okay.
we can have a scan around there and see
Yeah.
what they're up to.
Yeah, I'm interested to know what you are doing.
Yeah, we can have a chat to people in the lab and stuff.
Yeah.
Afterwards, yeah.
Yeah.
Yeah, we'll see if Jo's around, because she's been doing some late nights doing testing in the semi-anechoic.
Right.
It's one of those great tests where you walk past and there's a big hedge and the anechoic. It's cool, man. It's good fun. It's not big enough for it.
Maybe someone wanted to steal a table.
I was thinking the same.
You'll be glad looking at it. A lot of reaching. So, like a ordering past I think, well, no, I'm thinking the line. You guys want to
Depending on how many people have arrived by 12, we give them 5 minutes.
Yeah. Do you have a canteen?
There is no canteen in this building. There used to be. But a lot of those facilities have moved to different buildings.
What is that?
But if you needed lunch and stuff after this, we can sort
The
it
thing
out.
was,
Oh,
they still
I
have
need it.
places and also do the every vegetarian. Thursday night is a particularly vegetarian night. Well, the whole point is eating a little wooden creature.
Well, all keeps invited.
That's very important. Yeah, did we say we did? Well, I don't know what you said. I think Claire wanted to do some tomorrow, but then it couldn't happen. But yeah, I think the only thing would be.
You explain to me what this answer is.
Want to look? Oh yeah, of course. Yeah, we were thinking about doing like Luke. Right.
I thought it meant Luke.
Yeah.
He's used zeros.
Yeah.
Luke.
Yeah, how good.
Or just getting a clue.
Oh, there's not much stations.
I'm resetting. My clock is.
Yeah. Oh,
I saw there's a company there called Quantum Acoustic.
Yeah.
I don't really actually.
Mm-hmm.
I saw that. What is going on here? It's got like 20 sections. Quantum is onto that and it's like.
Oh, not full yet.
No, well, it will be. Don't you worry.
Yeah. We just passed some students.
No, so many people. I'd like to come in person though, isn't it? Vulcan is going to be sort of working at the same time to me joining the office.
I have to do it in person, especially when it's in the same building.
Yes.
So, well done for that.
Yeah.
It seems to make sense to do it here if you possibly could.
Yeah.
And also, I think the field might be well booked up.
Oh, no, okay.
Yeah, I can walk up to class.
Hey, Mark, could you just take a couple of photos when I present? I just, my company may want to use it.
Certainly, no
If
problem at
there's
all.
no problem for you,
No,
we may use on our social network.
And I can send you a link to the recording afterwards, so we'll put it on YouTube usually, so I can.
Okay, all right, thanks.
Everything that was whether or not that gets out there. Start being let out. Really? Yeah, I mean,
Oh, you brought lunch for everybody? Very nice of you.
no table bread.
Yeah, no table bread. Last time.
Oh, is it unmuted?
Yeah, I mean, we're gonna.
Well, you can get points last time there, so.
Ready to go? Next Friday.
All right, everybody. Hello. Welcome to second in our series of lunchtime seminars for 2024. We're welcoming today Dr. Shenzhi Su. Dr. Su received a PhD in building acoustics from Edinburgh and Napier University in 2009, did a couple of years of research at the university and joined Marshall Day Acoustics, providing consultancy for high-profile performing arts projects in mainland China and Hong Kong. Later, as the chief acoustician of Wonder Group, a large theme park developer, she supervised the acoustic design of over 30 theatres, film studios, outdoor performance venues and cinemas. She's currently with the leading multidisciplinary engineering consulting firm Kundal and is passionate about innovating solutions for real-world problems. And is here to talk to us today about using ChatGPT and Grasshopper for acoustic design. Hand off to you.
Good afternoon, everyone. I'm delighted to be here to share you my work on harnessing generative AI, focusing on the synergy of ChatGPT and Grasshopper for room acoustic design. This is a revised version of my presentation at the AOA conference last year. I don't claim an expert in AI, nor a coding wizard. I'm simply passionate about innovations. The fast development of generative AI in the last year opens a door to a wonderland of innovations, sparking my interest in exploring its potential. How fast is the recent technology advancement? Let's take a broader view of the history of technology. Brian Jefferson and McAfee, in their 2014 bestseller, The Second Machine Age, divided technology history into three phases: the pre-machine age, the first machine age, and the second machine age. The first machine age was driven by combustion and electric engines, and the second machine age powered by digital technology. Currently, we find ourselves at an inflection point in the second machine age, transitioning from internet era to AI era. They highlighted that digital technology is growing exponentially, which would primarily manifest in AI technologies. Exponential growth significance cannot be overstated. You must have ever heard of the famous chessboard story. The inventors of chessboard requested the king to award him rice by placing a single grain on the first square and doubling the amount at each subsequent square. By the time they reached the halfway point, the required rice exceeded the entire kingdom's resources. 9 years has passed since the book was published, and we are likely approaching the halfway mark on this metaphorical chessboard. The rapid growth in digital technology, primarily in AI, also means the rapid growth of innovations associated with AI. We are already experiencing quickest iteration of such innovations in terms of both quality and quantity. It also means successful innovations in AI are now generating financial values faster than ever. The McKinsey Global Institute estimates that AI could contribute an additional $13 trillion in economic output by 2030, thereby increasing global GDP by approximately 1.2 annually. McKinsey also projects that by 2030, approximately 70% of companies will adopt some form of AI technology, with nearly half of large companies implementing a full range of AI solutions. AI's value rarely lies in the product itself, but in its applications for real-world challenges. Professionals across various domains are now actively exploring its potential. First, acoustic professionals. How can AI technology generate value in the field of acoustics? How can acoustic professionals make the most effective use of AI? That's the question we need to answer. There are many ways to make use of AI. For example, collecting data and building an AI model using machine learning, collecting data to fine-tune a base AI model. These are powerful ways to make use of AI. However, these methods require a high level of expertise, also time-consuming. If you are currently engaged in such endeavors, I can only envy you. But for most acoustic consultant professionals, especially consultants like me, such applications are not practical. One of a practical but also effective way of harnessing AI for acoustic design, I reckon, is through generative AI's coding capacity and incorporating the code in existing software. This slide shows an analogy of digital and electric power transmission. Let's see the large language models. We can see the large language models are digital power stations, and the data is equivalent to fuel. The relative sizes of these slides for the large language models are proportional to their parameter sizes, which is an approximate indicator of how much digital power is installed. Internet infrastructure is the transmission grids. Fine-tuning process is equivalent to electric transformers to suit specific users. Professional software packages are equivalent to electric appliances. What are equivalent to plugs and sockets? My answer is customizable coding components within existing software platform. Rhino with Grasshopper, Revit with Dynamo, and Excel add-ins have such components. I'm also glad to see the new room acoustic simulation software Travel also include such a component. However, many existing acoustic software packages, such as Audion, SoundPlan, and Cadnan, don't have. It would be difficult for such software to access the digital power stations. It is my verdict. Those software applications with such a coding interface will thrive in the AI era, but those without will soon face challenges from a new generation of applications. How useful generative AI is for coding? This graph compares the popularity of 3 programming assistant platforms: traditional GitHub, Stack Overflow, and ChatGPT. The blue line indicates the visits of ChatGPT for coding by March 2023. You can see that the monthly visits of ChatGPT for coding exceeded traditional programming platforms in a month. Research indicates that ChatGPT results obvious improvement in productivity in coding. Following ChatGPT, a variety of generative AI coding tools have been developed within a year. The popular ones are listed here: GitHub Copilot Chat, Cursor, Google's Bard, Amazon's Code Whisperer, Meta's Llama, Cloudy, and Bloom. GitHub Copilot Chat and Cursor are based on OpenAI's GPT models. They are just fine-tuned GPT and repackaged to suit programmers' workflow. The most recent report, State of AI Report 2023, published on 12 October, concluded OpenAI's GPT-4 stands out as the uncontested leader in coding abilities. So, OpenAI's GPT models was the focus of my study. Grasshopper is a visual programming language plugin for Rhino to achieve a parametric design. Although room acoustic modeling software such as Audion, CATT are useful for predicting acoustic parameters, they often lack the flexibility required to interact with architectural models and study design iterations. Grasshopper, as a parametric tool, excel in these aspects. Grasshopper includes 3 types of programming nodes, which can accommodate Python, C#, and VB scripts. In room acoustic design for performing arts venues, optimizing the angles of reflectors for early reflections holds great importance, but can be time-consuming. My case study was to explore collaboration between OpenAI's GPT model and Grasshopper in optimizing reflector angles to maximize the projection of the first-order reflection energy onto the audience plane. This is a simplified model. The path node within Grasshopper acts as the interface between the two applications. OpenAI offers various methods which can be used for coding. We can get coding assistance directly from ChatGPT using free GPT 3.5 or paid GPT-4. OpenAI introduced custom instructions in last June, which include 2 questions to help users to set up system prompts. These prompts can be conveniently reused. This service is free if you use GPT 3.5. Last November, OpenAI introduced a new species called GPTs. These are in fact just packaged custom instructions for the convenience to switch among different custom instructions. Additionally, it includes some other powerful functions. For example, you can upload documents as a knowledge base for a specific usage. From 10th of January, that's just 2 weeks ago, you can upload your GPTs to the GPT store to earn fees based on the popularity. I created a GPT called Grasshopper Python Assistant. I don't expect I can make a great fortune for it, but you are welcome to try it. I will let you know how much money I can make. OpenAI also provides a playground which users can set up system prompts, user prompt, select models, and configure inference parameters such as temperature. This service is built according to the model to be used and the token. GPT-4 costs 10 times of GPT 3.5. OpenAI's playground provides a low-code fine-tuning service. You can fine-tune the model using your own data. It doesn't require much expertise in data training and coding. This service is built according to the model to be used and the token, which can be very expensive. The coding capacity of this method has been investigated and compared, except the fine-tuning method, which requires a large dataset of manually generated codes. One of my primary interests at the time was to find out whether the free service can produce code as well as the paid services. OpenAI's GPT's Python coding capacity were tested through the following tests. First task is create a high-level coding strategy. Very often, you probably already found generative AI have a difficulty to generate the code for a task in one go. The first step is often to craft a high-level coding strategy. According to the coding strategy, then the overall task was broken down into the following steps. And also these steps are used for test the methods. One is creating an omnidirectional sound source, non-founded rays received by a reflector, non-founded reflected rays received by audience plane, and the last optimizing the angle of the reflector to project the maximum energy onto the audience plane. Various methods has been tested for their capacity of crafting a high-level coding strategy. ChatGPT with and without custom instructions. The 5 methods in OpenAI playground, which use different base models, GPT 3.5 turbos, 16K, and another one is GPT-4. And using different prompt techniques. The specific prompts and their outputs are provided in my IOA paper. I will not repeat it here. It would be a bit boring. The findings are well-designed customer instructions improve the output quality. Differences in output quality by various tested playground methods are insignificant. Interestingly, playground GPT-4 with a well-designed system prompt performed marginally better among the 5 playground methods. ChatGPT based on GPT 3.5 with well-designed custom instructions perform as well as tested methods in playground, including GPT-4, most of the time. This is a good news as ChatGPT based on GPT 3.5 is free and all other methods will require a charge. Then we move on the first step of creating Grasshopper program. This step is to create the omnidirectional sound source. For an omnidirectional sound source, when they represented by rays, the endpoints of each ray on the radiation sphere should be evenly spaced. This is a very simple requirement, but actually is a very interesting mathematical problem. As it turns out, for more than 20 points on a sphere, it's impossible to achieve perfect evenness. Several mathematical models are available to achieving approximate even point distribution, but with varying perfections. Now, an intriguing question arises. Can OpenAI's GPT identify the optimal method and generate executable code without a specific guidance on which mathematical approach to employ? 3 sets of experiments using various OpenAI methods were conducted. Each set employing a different prompt technique. One using a prompt that directly describes the acoustic task. The other one is a prompt that describes the underlying mathematical procedure. And the third one is the prompt for prompt technique to enhance the prompt. As to use prompt to generate the prompt. The findings are prompt technique had a significant impact on the output quality. When using a prompt that directly describes the acoustic task, GPT had to translate the acoustic task to a mathematical procedure first. Introducing this procedure actually results in the lowest quality of code. While the prompt for prompt technique did enhance output quality, it didn't yield discernible differences when applied to the GPT-4 model. OpenAI's free service, ChatGPT based on GPT 3.5, consistently delivered the most satisfactory results when incorporated the well-designed custom instructions. On the left is the code generated by ChatGPT. On the right is the result. The Grasshopper Python code generated an omnidirectional source successfully. You can see this node is defined the location of the source, and this bar defined the radius of this radiation sphere, and this is defined how many rays we want radiate from the source. We can move the source wherever we want to do very easily, and we can change in the radius of the sphere and change in the number of rays. So this is a very good example. Without any modification, the ChatGPT generated the codes which can create this result. This indicates this problem has probably been widely researched in ChatGPT's training database. As the free service ChatGPT based on GPT 3.5 was found, its performance actually matched other GPT method. It was used to generate codes for other tasks. Finding rays received by reflector, finding the reflected rays received by the audience plane, optimizing the angle of the reflector to project the maximum energy onto the audience plane. Unfortunately, for all these three tasks, ChatGPT failed to generate executable code. The main problems include the confusion regarding the syntax of functions in two Rhino libraries. Rhino includes two libraries for Python coding. One is Rhino geometry, and the other is Rhino script syntax. Both libraries can produce identical geometry, but through different functions with different syntax. ChatGPT sometimes employ the functions from one library, but use the syntax of the similar functions in the other library. Another issue is to misuse of data types for function parameters. Some functions require geometric inputs into a Python node in Grasshopper as guides. Guides is unique ID numbers for the referencing geometry in the Grasshopper environment. Other functions require geometry input in its native form. ChatGPT seems unable to distinguish the two. Additionally, misused data types extended to distinction between lists and individual items. Some parameters require the data type should be a list. Some require this parameter data type should be an item. The ChatGPT seems cannot differentiate these two. Despite this, ChatGPT has proven very useful. It consistently excels in formulating the logic and the structure of the generated code. So if you have no clue how to start a task, just ask ChatGPT. Generally, they can give you quite good logic and structure of the code, although they have mistakes of in details. It can find the suitable functions and methods for tasks. Although they missed the functions in the two different libraries, but normally they can point to the right functions. So if you got a function, it doesn't work, you just check whether it's the function in another library. It can also assist the coding, improving understanding of function usage, debugging, code optimization, code testing, and code documentation. In fact, before I used the ChatGPT in the early of last year, I didn't have much knowledge in Python. With the assistance of ChatGPT, I created this Grasshopper program using Python. It includes 3 Python nodes. This one is define the omnidirectional source, which I just demonstrated how it works. And this one, the finding the best angle of the reflector. The third one is for display. After setting up the coordinates of the source, this is the coordinates of the source, then selecting the reflector you want to study, and the rotating axis, and setting up the total rotation in steps and rotation angles of each step, and select an audience plane you want to study. This Grasshopper application can find the best angle of the reflector. And by clicking on this trigger, you will see this process. You can see this start to rotate. And I also divided the plane to small square, and each square can calculate how much energy is received, and is give the indication. And this here gives how much percentage of energy this reflector received, and at last it will stop at the best angle. This one right now is stop here. Then this is the best angle, which can project maximum first reflection energy to this audience plane. Part of my study of ChatGPT, Grasshopper coding capacity has been shared on my LinkedIn from May to July. I have received some comments. This is the one comment. I'm unable to get ChatGPT to add 1 dB plus 1 dB successfully. I can't imagine how to use it for decoding. I don't know whether you have tried 1 dB plus 1 dB using ChatGPT. At that time, which is last May, I tried both ChatGPT, GPT 3.1 and GPT-4. Sometimes produce correct results, sometimes not. I tried it again just 2 days ago. The left is the using ChatGPT 3.5. It gives the correct procedure, even the correct equation, but the result is wrong. It's give 1.5 dB. Then I tried this ChatGPT 4. The procedure seems very similar, but when it goes to this step, then ChatGPT code interpreter. Yeah, it shows on the screen. So right now, ChatGPT, GPT-4, they have an innate function to call code interpreter to do mathematical calculation. This code interpreter is to convert mathematical equations to Python code and calculate the equations in Python. So, but using this procedure, the correct results are guaranteed. So actually, nowadays, the ChatGPT has solved the problem in the calculations. But if you use, but this code interpreter is not in the part, not incorporated in ChatGPT 3.5. So be careful if you use ChatGPT 3.5 for mathematical calculations. Another comment is, including examples in prompts can only improve the output for a while. Well, providing examples in prompts can enhance output. ChatGPT only has a short-term memory with a capacity of 4K tokens. For some models, it is extended to 16K tokens, as equivalent to 3K English words for 4K tokens. So ChatGPT forecasts any training received before the 3K words within the same conversation. OpenAI Playground provides models which has extended short-term memory. Also, when a new conversation begins, ChatGPT will lose all prior training. For users who wish to maintain their training, now we have to use the fine-tuning function on the platform. Another comment is ChatGPT confused sound pressure level with sound power level. This could be related to the temperature parameter of ChatGPT. Also maybe because it lacks training in acoustics. OpenAI's GPT has a temperature parameter ranging from 0 to 2. This parameter is a controlled level of randomness in the generated output. The default value for ChatGPT is about 0.7. It's important to note that one cannot directly adjust the temperature of ChatGPT. If you wanted to change the temperature of ChatGPT for coding purpose, we probably wanted the temperature to be 0. We don't want the randomness. Now we have to use OpenAI's Playground. Only OpenAI's Playground has the capacity to configure the temperature parameters. Another comment is I found if you just give it an open-ended question, it can struggle. My presentation has emphasized the importance of prompt engineering. If it's an open-ended question, then it's unlikely to have useful results. But even it's not an open-ended question, if the reasoning chain is too long, just as I explained earlier, then the output quality can be poor. Before generative AI became available, canvas-based programming in Grasshopper has the advantages over script. This on the right is a canvas-based Grasshopper program, and the left is a script. Why we use this canvas-based programming? Because in the past, if you know which node to use, or one doesn't need to understand the exact syntax of the node, and the input and output are explicit, it reduces the learning curve and making it especially popular for software packages that process geometry. However, you can see when this program, canvas-based program, get larger and larger, it's actually quite difficult to read. And it's also have awkward to handle the task like looping. And also canvas-based methods still require a significant investment of time to master. And you have to create an approach from scratch. Now we have the ChatGPT. Then I find actually it's easier to learn scripts than using canvas-based program, because the ChatGPT can provide the structure of the code and give you hints what's the function to be used. The effectiveness of ChatGPT in downstream tasks is significantly influenced by the underlying large language models. It's worthwhile to note that the same large language model version has been reported by users to have a drastically different performance over time. So everyone, we have to continuously monitor performance as well as update carefully created prompts. Some researchers have compared GPT-4 and GPT-3 over time between in March and June. You can see GPT-4's performance this is for math questions. GPT-4's performance actually reduced for math in June compared with March, and GPT 3.5 actually increased this performance over time. So this actually, if you have tried it, you may find their performance is sometimes not consistent over time. I don't know how many of you learn coding, and should acoustic professionals invest time in learning in coding? Although ChatGPT can generate code from natural language input, but as I demonstrated earlier, the generated code often needs to be treated before they become useful. If we don't have coding knowledge, then we will find where it's difficult to make use of it, at least at the currently. So because of the rise of generative AI, I think learning coding skills are more important than ever. But the good news is the research has shown that less experienced users benefit from AI as more than experienced ones. And they're using AI tool can improve the productivities by approximately 32%. So I think the investment of time in learning coding skills is becoming increasingly worthwhile and important in today's environment. Here is my conclusions for the findings. Prompt techniques can significantly influence the output quality. Free service ChatGPT based on GPT 3.5 with well-designed custom instructions can produce code with a quality matching paid method offered by OpenAI. The code generated by ChatGPT was often non-executable, primarily due to syntax errors. Manual refinements are required. ChatGPT is still a valuable tool for coding and increasingly becoming powerful co-pilots for acoustic software. Acoustic software should support coding with generative AI. Possessing coding skills can increase productivity more than ever. The investment in time in acquiring these skills is increasingly necessary. Just before the new year, I discovered Maxwell's birthplace just located 5 minutes walk from my flat. You probably know Maxwell is Scottish. I'm travel from Edinburgh, and right now I'm living in Edinburgh, and I visited his birthplace, and it has a demonstration to show the transmission of electromagnetic waves. That equipment was originally designed by her, and you can see the spark of the 2 ends of wire on one side, and then one is at the right frequency, and then you can see the spark in the room in another location. And this is proved, is Hertz designed these experiments to prove the Maxwell's theory in electromagnetic theories. Just at that moment, I suddenly realized we are constantly in a shower of electromagnetic field because we're in light. And you know, lights are electromagnetic waves which can be perceived by eyes. Actually, I knew it while I was in school, but just at that moment, I knew it by skin. It seems penetrated through the languages. This generative AI are based on large language models. This demonstrated the power of languages. Through a language, this can master very complicated tasks, but it may also its limitations. I'm just thinking, what's the difference between human and artificial intelligence? It may not like saying the language. If you have ever experienced that moment, you can penetrate through language to perceive certain phenomena. You probably can understand what I mean. This is very difficult to convey through words, through language. This reminds one Chinese classic called Debugging. I'd like to finish my presentation with the first paragraph of Debugging, which was written 2,300 years ago. I think this let me think about what's our consciousness and what's artificial and human intelligence, and what's the role of languages in our thinking and perception. The first paragraph is saying that the Tao that can be spoken is not internal Tao. Tao means the way or how things as it is. And the name that can be named is not internal name. Nameless, the beginning of heaven and earth. Named, the mother of 10,000 things. Yeah. This is, if you have any questions and ideas you would like to share, you're welcome.
If there are any questions in the room for Dr. Sue. Yep.
Oh, thank you. Where was the ray tracing part of this done? Was that handled by this Rhino Grasshopper software? Does that do ray tracing? Because it looked like there was some ray tracing going on.
Yeah, you can write the code.
So the code was doing the ray
through
tracing.
the code. It can define the location of the ray. You can see I create an omnidirectional sphere. Let's use a mathematical equation to create. Then you use it. Then they draw the ray to the reflector and find the intersection point, and then also it's through their functions in Grasshopper Python.
Okay,
and
so,
you can
so
draw
the AI, you were using the AI to write Python modules, which you put into Grasshopper.
Yes.
So you're kind of doing it that way. Got it. Thank you very much.
It's a Grasshopper is a very useful for geometry and analysis. It's not just limited to room acoustic design. It may be able to use it in other situations.
Any other questions at all? No? Oh, Zach. Yep.
So it's great to see it used in a room acoustics situation.
Mm-hmm.
Have you tried anything in sort of the more environmental, industrial noise propagation side?
I haven't yet, because there are seems there's no such needs at the moment. We just use the like a sound plan calendar to do it. But for room acoustic design, as I explained, audience cannot do the task. I just demonstrate, and this task actually quite important when you design an auditorium. But certainly they have room for it.
Any further questions in the room? Yeah, yep.
I noticed you didn't mention the API, ChatGPTs. OpenAI have a sort of back end that you can access. Have you tried doing anything with that?
I mentioned the OpenAI's playground.
Yeah.
That playground is for using API.
Right, okay,
Then you can use use OpenAI's GPTs in the software you designed.
Yeah.
I'm designing a mobile app which can take field notes quickly, and I included the API, GPT API in my app, which I can access OpenAI's GDP in my app and answer the questions and add it to my note straight away. Yeah, this certainly is a very useful function if you are designing a software.
Yeah. What was the app called? Is it not got a name yet?
It hasn't marketed yet.
Okay.
I'm designing it. Currently I named it as I feel the notes.
Okay.
I will let you know when it's on market.
Sounds good.
Thank you. Anybody else? No? I had a quick question, well, two quick questions. You mentioned that the GPT, it's better at doing code than mathematics, and then there was the example of it can't add 1 dB and 1 dB. I was wondering if you had the sense that it could, if you asked it to write code to do that, do you think the code would be successful?
I think the code is different from mathematical equations. You generate code that follows the logic. Yeah, there are some errors, as I mentioned, but it's generally their logic very good.
Yeah.
But they just, I don't know why they just cannot, even with the equations, they cannot calculate.
So it gets the logic correct, but then the results are wrong. Yeah.
But they have mistakes in details.
Sure. Yeah. And then the other question I had is that there was, you mentioned GPT 3.5 with a custom prompt gave you the best result.
Yeah.
But that GPT-4, it didn't really make any difference using the custom prompt.
I don't see, actually in my trials, I didn't see much differences in quality of their output.
Right.
Yeah.
So they were broadly similar, it wasn't drastically different.
But GPT-4 just to start from last November, they have incorporated a code interpreter and also web searching functions. I think this is external functions incorporated in GPT-4, which help their quality.
Right. Well, that's it. Unless there are any more questions in the room, I have not received any on the chat. So let's have a round of applause for our speaker. Thanks again for coming. Thanks, everybody.
That's good to know. The expensive one. 3.5 is no
But now, maybe right now it's worthwhile to pay because right now GPT-4 have three additional functions.
Right.
One is can serve the search website.
Yeah,
The one they can do the mathematical calculation. Third, is can generate pictures. Yeah. So if you just use it for coding, I think it's not a great difference.
Where would we be?
Thanks again. How did you do? Is that okay?
Yeah.
I think it went really well.
Yeah. Thanks.
Did you have like peanuts in there?
Yeah, all sorts.
We're going to have a look around that.
Sure, yeah, the hedge isn't in the middle at the moment, so the debugging little hedge is in there, but somebody can move it out. But yeah, it's no problem. Yeah. Thank you very much.
All
You're
right.
welcome.
Thanks.
So would you like to have a little tour around the lab?
Yeah,
Some
that's great.
Yeah. Happy to.
I've done some commercial work in the transfer. So we might only be able to pop that head in. See the back. Oh, that's a good point. Thank you.
Piece of Owen.
Sorry, can I just get the microphone back?
Oh yeah, Thomas is still.